Welcome back in our channel. Today we will have 3 examples about different roots of the characteristic equations. The first case, when the roots are real and distinct. They are different, but they are real numbers. The second case, when the roots are complex conjugate. And the third case, when the roots are real and equal. And we have a special case about this one, when lambda 1 equal minus lambda 2. They are equal but opposite in sign. So the first example here we have y double prime plus 11y prime plus 21 equals 0. And our initial condition is y at x equals 0 and y prime at x equals 0 equal minus 7. The characteristic equation, lambda square plus 11, sorry, here is lambda. Plus 21 equals 0, so the roots are lambda 1 equal minus 8 and lambda 2 equal minus 3. They are real numbers but different. They are not equal. So here are our solutions. This is our solution. And here is, we insert minus 8 and minus 3. This is the solution. How to find the constant C1 and C2? We apply our initial condition, which is y at x equals 0, so here 0, and every x we put 0, so we go C1 minus C2. This is equation 1. The second, y prime of x at 0 equal minus 7. And this is equation 2. We solve equation 1 and 2, and we found C1 equals 7 over 5, C2 equal minus 7 over 5, and here is our solution. The second case, when the roots are complex conjugate, like lambda 1, 2 equal A plus minus BI. Okay, so now we have this example. I'm using 2 types of notation just to be familiar with our notation. So this is the second derivative of y over dx squared plus 2 dy over dx plus 4y equals 0. Here our initial condition, y at x equals 0 equal 1, and the derivative at x equals 0 equal 1. Here is our characteristic equation, and here this is the quadrant formula, and we found lambda 1 equal minus 1 plus root square of 3i, and lambda 2 is the conjugate of lambda 1. This is our solution. This is our constants, and here A, which is equal minus 1, and B equal root square of 3. Again, we insert the initial condition, and just as we did in the first example, and solving 2 algebraic equations in terms of C1 and C2, this is our solution. The third case, when the roots are real and equal, they are repeated. Lambda 1 equal lambda 2. So here's our example. The initial conditions is this one. Y at x equals 0 equal 1, and y prime at x equals 0 equal 3. This is our characteristic equation, and these are lambda 1 equal lambda 2 equal minus 2. They are equal roots. So our solution will be like, it comes on this form. You see, you can see this is x, but here there is no x. Applying our initial conditions, we find C1 and C2, and this is the final solution. See, e to the power minus 2x plus 5x, e to the power minus 2x. This is we have a special case of 3, which it says if lambda 1 equal minus lambda 2, they are equal but opposite in sign. The solution will be like this. Hyperbolic function. Again, we find C1 and C2 from any given initial conditions. Thank you for watching my videos. The next video we will have a applied example from electrical engineering, the RLC circuits. And until the next video, have a good time, and please subscribe to my channel, give me your likes. Thank you very much.